folks that I've known for a long time and folks that I really hope that someday I'll get a chance to meet. We've got 3 terrific presentations today that I think you'll find as interesting and thought-provoking as we enter into this sort of new world of ferry design, as we look at how do we reduce our emissions, how do we improve our environmental footprint. We've got 3 presenters today who will be throwing ideas out there, and I encourage you all to be scribbling down your thoughts and questions because following the presentations, our intention is to have a Q&A session. And assisting in that Q&A session will be a good friend of mine, Chris Berry, who will be leading that. And I'll give a little bit of the biographies of our speakers and of our chief questioner, Mr. Berry. Leading off the presentations is Stuart Ballantyne. For those of you who have participated in Interferry, Stuart has been a leading figure there in terms of calling for safer, better ferry designs, saving weight, improving the environment. And Stuart today will be bringing his many years of experience in vessel design to be talking about sustainable vessels and how do we improve the safety. So I like from Stuart's biography, his likes are family, fun, boats and ships, and dislikes is anyone who doesn't bother to find or use their talents. So that speaks well of Stuart. Our second speaker is Mr. Erik Eklund from Candela Speedboat in Sweden. For those of you who have been following the technology, our friends in Northern Europe are doing some very exciting things. Mr. Eklund has been involved in ferry system in Sweden, was involved with the government of Dubai in setting up some of their maritime safety sector. He's a naval architect by training, and the title of his presentation is The Game Changer, Reinventing Waterborne Public Transport. So really looking forward to hearing that. And finally, our third speaker was a little closer to home to us here to me here in Seattle, is Elias van Sikkel. Elias is going to be talking about the world of zero emission ferries, most specifically hydrogen-powered fuel cells, and of an actual vessel that's under construction to demonstrate that technology here in the States. Elias is Director of Development for Switch Maritime, and he'll be speaking to you about some of his knowledge of the combining hydrogen fuel cells, batteries, and propulsion motors to create a zero-emission vessel. And as I mentioned, last but not least is Mr. Chris Berry. Chris is a fellow graduate of UC Berkeley. He's worked with shipyards and design consultancies around the world. And for the past number of years, he's been very involved with the US Coast Guard's own engineering center in Maryland. He's a fellow of the Society of Naval Architects and Marine Engineers, and is certainly an innovative thinker. And so with that, Roberta, if we could roll the tape on the first presentation, sit back and enjoy.
Okay, I'm just gonna set up the screen share. Okay, and then stop.
Good afternoon, this is Stuart.
1 minute, and now let me get to screen share. And there we go. And here we are. And make it bigger. And go.
Valentine from Australia. And
I'm going to ask, I will ask Mr. Chris Berry to give us his initial take on what he heard today. Chris?
And welcome to the 5th concert of our series Live from St. Mark's.
Oh, what happened?
I'm Richard Patterson, the director of the Omni Foundation.
Excuse me, I'm sorry, I don't know what
tonight's concert will feature
Ooh.
one of the bright stars of the classical guitar.
Sorry about that.
Chris, I think
Chris,
you're muted.
yeah, Chris, you are co-host now. And Gina, can you make Elias and Eric and Stuart also co-hosting, or at least unmute them? Well, they should unmute. Okay, great. So welcome, Chris.
Well, you know, it's required that someone not take the mute off when they're talking in a Zoom meeting. And that's the only way they ever work or don't work. The issue of foam ship, I was wondering what sort of foam they're using. Our ISO 12217-1 has a couple of different options for foam in smaller vessels, and that are supposedly, of course, unsinkable. There's a specific definition of unsinkable in that case. But one of the things that when we build, Coast Guard builds ISO 12217 boats that are category B or C, which are which are one of the unsinkable options.
Chris, your sound isn't there. Chris, your sound wasn't good. Your first question was about the foam, and maybe we'll let Stuart answer that, and then maybe ask a second question, because somehow the second question got the sound quality. So, please.
So Chris, to answer your question, we've been working for the last 4 years with a company called Minova and Strathclyde University on these instant bulkheads for firefighting and watertight integrity. The problems with the previous foams that were in the industry, available in the industry, was the high toxicity level. In fact, if they caught fire, the carcinogenic level would quickly kill you. So this is a new development that we've been working on, and we see that in the testing, for instance, we're trying to set it on fire, etc. We've got to the new levels that previous foams haven't got there before. And we've been going through this process of class approval with DNV, GL, and LR. We've also presented to AMSA here in Australia about this application, and we believe that this is finally the way forward. Unfortunately, the tragedies of foam previously, when it did catch fire, it resulted in a number of deaths in the German shipyard, for instance, when all the foam in a reefer ship caught fire, and it sort of took a back seat for many years, in fact decades. And we're re-looking at this so that we've put this in. We have a rule in Australia: if we have fixed foam, we've actually got to take it out every 10 years, which is just crazy. So if we can do this, we're just trying to get over that particular regulatory hurdle. But we see that if it's, in this presentation I was saying, you have to do this from the beginning of the design. And we're actually we've done one vessel already, which is the one I showed you, with my own vessel. And we're building 2 more at the moment, one will be a survivability index of about 85, and the other one will be 100. Okay, Chris.
Well, yes, that's the problem we have had was with blown-in foams. They're toxic to put in, so Coast Guard doesn't allow them for its own maintainers. What we've had to do then is use shaped foam, sheets and sheets and sheets of shaped foam that is either polyurethane, polypropylene or polyethylene, or beaded polyethylene and beaded polypropylene, or one of the structural foams. Of course, they still will burn, although not so vigorously. But the problem, if it's a blown-in foam, the other problem we found is that we get the interface between the metal hull and the foam gets crushed by small vibrations, and then we have water absorbed on the fairing surface, and that causes corrosion. So there are some issues with foam that have to be thought out carefully, and fire is one of them, and that's good that you're doing that. The other one is the issue of fairing surface corrosion between the foam and the metal.
Chris,
So,
do you
of
have
course,
a question on one of the other presentations for the group to consider?
well, one of the other things is I see 2 aluminum boats in this thing, and I would certainly encourage people not to paint aluminum. The business case for it is you have to maintain it, clean it, all this other stuff. The alternative is to give it a special blast and then don't do anything in the future, which is a pretty simple, doing nothing versus doing something is always a better business case. And the Coast Guard's spent a lot of time developing a nice blast to produce a useful finished surface, and it's readily available in the old color and coatings manual, which you can get from everyspec.com and a lot of other sources. And but the point is, I'd encourage anyone building an aluminum boat not to paint it above the water line. It's cheaper and easier, and more important, less environmental. The paint you use with aluminum is not exactly environmentally friendly, nor are the techniques for prepping the aluminum.
Yeah.
The other thing I worry about hydrogen-powered vessels is, where does the hydrogen come from? And I can't say I really understand all the distinction, but I hear about black hydrogen and green hydrogen and blue hydrogen. I'm not sure what all the colors mean, but
yeah, I'm happy to jump in on that, Chris. And I also see there's a couple questions in the chat here from folks, so I can run through some of those.
Thank you.
Maybe I'll start with, let's see, I'm looking up at the chat. The first question is about efficiency loss. It's from Eric, going from hydrogen to fuel cell and back to electricity. It's a great question. As I noted in the presentations, the fuel cells that we're using are somewhere around 55% efficient at their higher range. And then, Chris, I'll loop in your question. It really depends on the full efficiency through the whole chain depends on your method of hydrogen production. So SMR, steam methane reforming, is one of the predominant ways of producing hydrogen today. That's in that gray hydrogen category. Blue hydrogen pairs steam methane reforming with carbon capture, and then brown hydrogen is probably the dirtiest, and that's from coal. All those involve basically splitting methane, which is CH4, the molecule, and then we get to the other side of the spectrum, which is electrolysis, is one of the predominant ways of green hydrogen production, and that's using electricity to split water. That efficiency is somewhere around 80%. So I hate to say it depends, but it kind of does depend on which method of hydrogen production you're using. What really tips the scales towards hydrogen is that we simply can't sometimes fit enough battery on board to make a ship go fast or far enough. And that's where hydrogen's energy density comes in, because it's so energy dense. It's one of those zero emissions options that helps us achieve those further and faster routes. And I'll say just one data point to put that in perspective, and then I'll pause, is a Tesla Megapack has about 3 megawatt hours of energy storage per 20-foot container. And so that's just a spatial kind of size data point. And our 242 kilograms of hydrogen storage on the boat have about 8 megawatt hours of energy in that hydrogen. And so that'd be at least 2 full 20-foot containers worth of battery to get the same amount of energy on board our boat as is contained in the hydrogen. So that said, I mean, I'll connect it to Eric's presentation. Last thing is, I think, I do see a complementary role for efficiency measures like hydrofoils in concert with, zero emissions vessels, so that we can bring down the energy requirement as kind of a baseline. So bit of a long answer there, but that's question number 1. And I'll pause if there's any other questions, and then I can continue on to the next one I see in the chat.
Someone is asking you about the fire risks of the hydrogen pack.
Yeah. So this is it's a non-zero risk. Obviously, there are, like any other fuel, there's fire risks. But I think, our stance is that just like any other fuel, if you're following the established procedures in a safe manner, then it shouldn't be like it should be exactly like any other gas, where safe procedures equal safe operation. And that is backed by a long track record of safe operation in the hydrogen space. There's about 70 million tons of hydrogen produced globally, and 10 million tons produced in the US alone. And there's a long track record of safe operation in passenger cars, buses, trains, and forklifts, among other transportation applications at this point. And then,
Eric? Were there some questions for Eric? Let me see. I know I have a question of Eric, if I could jump in. Eric, you said that the cost of 4 vessels is less than 1 vessel. And can you sort of run through the numbers briefly so we can understand that? Are you talking about capital construction costs or operation costs, or both? Thanks.
Yeah, hi, thanks for the question. The thing is that the operation cost, it's mainly 3 parts. You have the fuel, maintenance and service, and you have the crew. And if you can minimize fuel costs and maintenance cost by like 90%, and then also reduce the crew cost, because you have a smaller vessel, so you can actually have like 1 crew in many countries, and also with a lower education level, because it's a small vessel, then you have a very low cost for the operation side in total. And the capex is actually around the same for the same vessel for a diesel version for the same size and speed. And that's give you a really, really good business case for having multiple smaller vessels instead of 1 large. So if you look for us, and also for the larger one, it's very, very seldom that this 100% seats are occupied. And then that makes also, if you look, you have maybe between some of the stops on the line that is more higher density, then you can actually put in some more smaller vessels in just between these certain stops, and not for the full line. So that gives a very, very interesting case if you look for the operation.
Yeah, thank you. I think that's an important point, and I know that frequency is very important to passengers. So thanks.
Yeah, it was maybe some more questions in the chat. I answered just one of the takeoff. It was the speed. It's a matter of design, as I write in the chat, because the efficiency, you can see it as when this kind of boat is going slow, it's like any other boat, of course, until it actually start to make waves, because that's when they actually get to the start loss of energy. So our vessel is consuming the same amount of energy in 5 knots as in 20-25 knots. And that is the big difference compared to a normal boat. Was it any more questions here? Did I miss something?
I had another question of Stuart. Stuart, what kind of vessels have you actually built, and what kind will you be building? Are they passenger vessels or recreation or what?
Good question, Roberta. The first one that I've done is my own boat, which is a 60-foot motor sailor catamaran. And the one I just showed you on the sketches is my boat. So there's nothing like putting your money where your mouth is. and trying to get the regulatory authorities to agree to it, because I took out the collision bulkhead on the port side, and of course you can't do that as far as the local regulators are concerned. The second two is a 60 meter and a 70 meter, which we're doing part foam on the 60 meter, and we're doing a full foam system. Full foam systems, we say, where we take the survivability up to 100, so it becomes unsinkable. And I've seen Aurore's comment there is question, are you going to put all these lifeboat manufacturers out of business? That's not the intention. It's just to try and make these vessels a little bit, to make the vessel the lifeboat, becomes the lifeboat.
Are your upcoming vessels ferry boats, or are they also,
yes, they're ferries, the passenger ro-ro ferries, yes.
Oh, ro-ro. Are they for a particular market? Are you ready to say, or?
For the global market, no, it'll work for the global market, because we've done the CapEx forensically. CapEx, in other words, what we can save on internal painting systems, and this is an important message for Chris, of all the experiments that we've done. We don't have any air gaps at all between the skin of the vessel and the foam. There's no air gaps at all. And there's a process that you have to follow to do a proper installation of foam. You just can't sort of throw it in there on a 2-pack mix and hope it fills all the voids. There's a proper procedure. We've tested it for burning. It does not burn. It does melt, but it doesn't burn. And we've got the toxicity levels down. So we're happy that we've got class and flag approval. So there we go.
Okay. Okay. And I guess, Elias, I noticed that Hornblower is one of your supporters. Any interesting scoop on that story?
Sorry, keep going.
I'm sorry, yeah.
Yeah, Hornblower is great. I think there are some folks that I work with very closely in the audience here. Nothing but the best to say about them. I will say that they're part of our construction management team and have been doing a fantastic job. And we may have some more press coming out in the near future regarding where and where the vessel will be operating. So I'll leave it at that. I do see, if I may just real quick, I see 2 other questions in the chat about the location of fuel cells. So generally our approach here has been kind of like an iterative design process, where we first try to have the first vessel be the path of least resistance for regulatory approval. And that's the fuel cells in the back of the ferry in a fuel cell room, and then the hydrogen tanks up above. And over time, we intend to make those designs more space efficient for passengers and enable more passenger space to be opened up, but in due time with just incremental changes towards opening up the top deck, and then maybe putting the hydrogen storage and potentially the fuel cells below deck.
Yeah. Thank you. I see Ethan has a question. Ethan, you want to sort of say a few words?
Sure. Thanks, Roberta. Stuart, question for you. How does foam filling void spaces impact or complicate hull repairs for steel or aluminum hulled vessels in the event of damage? I imagine this limits or complicates the ability to conduct hot work. Can you speak to that a little bit?
Yes, Ethan, good question. And it's been a consistent question through all the presentations over the last couple of years with class and also with flag. And because this material doesn't ignite, it just melts. What we have done, we've done practical tests where the welding is done on one side, and then we've opened up and examined the other side. And it melts a little bit, but doesn't create any problem. So where we have to for instance, crop and take a plate out, a damaged plate, we would cut out as we would normally do it. We would plug weld the second plate in, and we would leave 2 side plugs that we would inject foam into the void after it's been repaired.
Thank you very much. A quick follow-up on that, if you don't mind. Do you foresee any problems with hull structure getting sort of entrained in the foam and complicating removal. So if you had a L or T-shaped longitudinal that's sort of encapsulated in foam, would that make removal a little more complicated, or do you not foresee any challenges there?
No, we don't see any problems. One of the interesting things, guys, is that, following Chris's comments on aluminium, is that one of my mad friends here in Australia runs 35-meter catamarans, and he foam fills everything. He's done that for 20 years. And quite often he's asked to cut a piece out by the oil people that he works for, the offshore oil rigs, and cut this out and put this piece in. When he cuts the old piece out, it's been there for 20 years. When it comes out, they have to extract it, and the foam comes out with it. When they scrape the foam away, they find that the texture marks of the tradesman that put it together 20 years before is still there. So it's in pristine condition. So, and that's the way that it should be. So what it does in the end, it elongates the vessel lifespan. So, but it's a good question.
Do people from, our participants, our audience, have any questions? Like Carl, you build ships. What do you say?
Yeah, thanks, Roberta. I just typed a long question, but first of all, I want to make a comment to Chris Berry. Yeah, we totally agree that there's no really reason to paint boats anymore. It adds a lot of weight. A lot of operators are going to the vinyl option, which is a lot less weight and a lot easier to repair. But I have a question to Stuart. Years ago when we first started building some of the smaller U.S. Coast Guard boats that had foam collars manufactured by Wing, which is a great company, great product, we found that if you do not paint the aluminum behind the foam and you put the foam on there, that water has a way of finding a way to get everywhere, but that water can get behind that foam, and then it can start causing a corrosion behind the foam, and you really don't discover that until it's way too late. Have you found that it will be necessary to paint those voids before the foam is applied, or do you think maybe not? Have y'all looked at that at all?
A good question, Carl. As I say, my friend Horst Fischer, and he's happy to give testimonies. He never paints his vessels inside or out, and he foam fills everything. And he's been doing it for 20 plus years with closed cell foam, but he hasn't been using products as good as the one that's now come on the market. And he reports zero corrosion at all. The other interesting thing, we have a condensation corrosion from underneath the island bars of the vessels that run out to the barrier reef, where they have island bars with, where all these bikini girls serve from the fridges to the bars either side. Below that, on the bridge deck structure, if you don't paint it or don't foam fill it, it gets condensation corrosion such that it destroys the whole bridge structure. And I've seen it myself, where underneath the being in dock, looking up at the bridge of this 30-meter catamaran, and it was just all white calcareous powder from the condensation corrosion below the bridges. So interesting.
Right. Thank you.
Good.
Roberta, can I ask a question, please?
Sure, please. Hello, Nora.
Yeah, thank you. This is on Eric's presentation. I know, Eric, it was a very good presentation. You did respond to my question in the chat, I can see. However, I have a bit of experience with hydrofoils being used in inland waterways where there's a lot of water hyacinths. So they had problems, probably the earlier versions, but you said that from England to Channel Islands, they did not have any problems. But when you go into rivers and lakes where the tourism is there, there are water hyacinths and similar growths. And my question is, have you thought about that one? And how would you overcome this challenge? My second question is, what is the largest size of what hydrofoils that you are trying to do now?
Good question.
Yeah, thank you for the question. I start with the second one. I mean, you can actually make quite big ones, but the efficiency is going down compared to like a very super efficient catamarans, for instance. So it's getting narrow, more narrow when the ship size is growing. We still think that we can have like 100% more efficient at 300 passengers than compared to a super efficient catamaran. But as we see it at the moment, we don't have the better business case for going large. We can still find it with smaller sizes. Of course, we can build larger than this 30 passenger one that we are building for Stockholm, but it will not make the business case better to have super large ferries. That is the second question. If you're looking for the first one, we have been testing it with the areas with a lot of seaweed. And the experience is that, of course, if you get something on the hydrofoil, you get higher resistance, but the seaweed is normally not stuck. It after some time, it's actually getting off, especially if you increase the speed. So we have not tested it in so many areas yet, but so far it hasn't been a huge problem for us. But of course, it might be a problem in some areas that we have not tested yet.
Yeah, thank you.
I see that Farn, who has the biggest and best ferry operation in Bangkok and probably Thailand, had a question. Do you want to verbally ask your question, Farn?
Hi, Roberta.
Hi.
I got the answer from
Okay.
the Switch Maritime already, and we're chatting right now. Thank you.
Oh, okay. So what was your question now? Turnkey solutions. Okay. And you were asking Elias about turnkey solutions. Okay. And you're...
Yeah, real briefly, I'll just summarize what I said. We can provide turnkey solutions with clean fuel supply chains as well. Generally, our bareboat lease model is quite simple. We just provide the capital for construction, and then we bareboat charter the vessel to operators, and we have our returns on that capital deployment that we just bake into the bareboat rate. And so happy to provide more detail to anyone offline.
Okay, thank you. I see we have a lot of students here, and the students will be presenting tomorrow at this time. Many of them are the awardees of the design competition. Do any students have any questions now that they've been grappling with ferry design? Anyone? No? Imam? Johannes? Play feed? No? Okay.
I have to go, Roberta.
Okay. Yes, I know it's some, but thank you very, very much. You can see that was tremendous interest, and it's good. You'll keep us posted what's happening. Okay. Take care, Stuart. Yeah. All right. Do any of the professors have any questions? No. Okay. Well, I think I'm just tremendously excited by this. I guess very excited about both the hydrofoil and the candela. The candela. They're both exciting. I like the idea that we can have small vessels and they're very efficient, and it's better for the customer, and a sort of a sense of mobility as a service, that the vessel is there when you want it. So that's all great. I guess with that, are there any other questions? Okay, so for those of you who are here, please come again tomorrow. You're going to hear the students, and our moderators are Captain Nura Rahman, who you just heard from, as well as Charles Cushing, who is another well-known naval architect, and both judges of the design competition. So we look forward to seeing many of you tomorrow. Okay, thank you very much.
Thanks,
care.
Roberta.
Roberta.
Okay.
Great job.
Have a
Good night,
good day.
Roberta.
Good night.
Thank you, everyone.
Al?
Thanks.
Yes.
Thanks.
Thanks.
Bye.
Great, Ed.
Thank
Thanks, Roberta.
Yeah. Sonia, we'll see you tomorrow. Thalia, thanks for coming. Okay. All right.
Thank you, Roberta.
Thank you. Thank you, Fawn. It was great to see you.